A lot of people take this particular, well, actually, a lot of people in general take a lot of the beginning sections for granted, and then they run into trouble as things get more complicated because I start referring to things certain ways, and then they don't know what I'm talking about. So make sure that you take heed with what we're actually learning right now. Don't just fly through it. I will not ask you necessarily for a strict definition of any of these right here, but I'm hoping that you know what they are. But remember, defining things is sometimes more difficult than you think. You can probably draw me a picture, but can you actually put it to words? For example, does anybody believe that they can tell me what a polygon is in actual words? Okay. Yes?
Anything with three or more sides. Shape.
Okay. Oh, that's pretty good, actually. If you start saying, 3 or more and it connects, that's pretty good. Basically, their definition is a closed figure in a plane. So does what I drew in red there meet that definition? Is that a closed figure in a plane? No. Okay. We probably should say that the sides are straight, but we keep it pretty straightforward, obviously. That one's closed. Straight sides, we're good. Again, I'm keeping it pretty straightforward for you. You don't want any arcs in there. That's no good. Okay. Well, sides. That one's probably a little bit easier now that we're going here. They are basically just, well, this one has how many sides? The one I drew in red has 5. And well, how can you describe those? Those are segments, right? And so that's basically the segments that make up a polygon. So I think you probably know that. Vertices. Well, how many vertices does this one in red have? Well, how could you describe them? Yes. Ooh, very nice. The points where segments intersect or meet, like we were just told. Very good. Not sure why they're not lined up, but close enough. And I'm hoping you know triangle because my 3-year-old knows what a triangle is. Yes, complete coincidence on the age. But he is very straightforward, and he tells me very specifically what it is. Okay? Polygon 3 sides and 3 vertices. And if I ask him, he can point out the vertices. He can point out the sides. So I'm hoping you can. Well, I know you can't. No. Yes? Does he call them vertices? I'll have to check. But I called them vertices. Then I switched it to corners, and that helped him out a little bit. So I'll have to see if he'll actually call it a vertice. We'll check. Another little experiment. So those are pretty straightforward, right? I mean, that's not anything new. Okay. Key is that vertices are going to, what do you think, capital letters or lowercase vertices? Yeah, because points are supposed to be capital, right? Okay. So let's take a look at this particular polygon over there that happens to have 3 vertices and 3 sides. So obviously it's a triangle. We are going to then list the vertices. Well, that's very straightforward. Do you have to list them in order? No. Do you have to list them all? Well, according to that, yeah, you do. Right? But you do not. In this case, if all they're asking for is vertices, you can list them in any order you want, but most people just do it alphabetically by default. Okay? Sides. Well, we know there's 3 of them. And we know we got AD, we got BC, and we've got CA, right? Is that good? No, it's not. We called sides, by definition, are segments. And so that's not good. Because I'm saying the distance from A to B right there, right? When nothing's above, that's what that means. Remember that? So now if I do that, well, now we're good. And is it okay to say maybe AC? Yeah, that's fine. Yep. And BA is fine. Angles. Well, remember, you got to be careful with angles. Is it okay to just use the vertice on these? Is it okay to just say angle B in this picture? Would we all be looking at the same angle B? Sure. Okay, it's fine. Or you could always say, CBA or ABC. That's fine if you want. But if we're all looking at the same thing, angle C, are we all going to look at the same angle? I sure hope so. There's not another one shooting out of here, right? So we're probably fine with that. And again, angle A is probably fine as well. But be careful, because you remember, as things have been going this year, the pictures get a little more complicated when you get to your homework. They make you think a little bit, right? So make sure you look out for any of that. How about naming the triangle? Do you suppose mathematicians are going to write out the word triangle?
No.
No, no chance. That's past like 4 letters. There's no way. And so, of course, we're going to get very clever and put a little picture in front of it. Triangle. And all you have to do is you start with a vertice, it doesn't matter, and they either go clockwise or counterclockwise. It does not matter. All right? And it's always fun for me to write them down and then see if people can tell me if it was clockwise or counterclockwise. It's always interesting. So let's say I started at A and then I went to C and B. Did I at least go around in a particular direction? I did. Now with a triangle, can you really mess it up? Not really. Now with other polygons, is it possible to mess things up? Most definitely. Okay? So we'll talk about that in a second, but in fact, I think we talk about that in another chapter. But anyways, did I go clockwise or counterclockwise? Yes, because the clock goes this way, right? That's how the time goes. That's clockwise, and that's the way I went around it. All right, very good. If you didn't know that, well then, you learned something today. Spin the triangle above. I guess it's kind of above, right? Or for you, is it above? Yeah, iffy, right? Off to the right, maybe. Which side is opposite angle C? Well, if we're talking about angle C, we're talking about this one right here. So which side is opposite? Well, what does the word opposite mean to you? Well, over there, right? So which side is that? It is side AB. Is that okay? Once again, no. All right, segment AB. Now that is okay. Well, can you do that in the reverse? Can you say which angle is opposite AC? Well, if this is AC right here, which angle is opposite that? Well, you go over there, it's angle B, or maybe this time I'll say A, B, C, just to remind you that's how that could work, right? It'd be this angle right here, A, B, C, right? Again, is angle B in this picture okay? Yes, it is just fine, because there is no other angle B that could possibly happen. So those opposite ones will prove important as the year goes on, so make sure you can do those. Okay? And again, realize that if the picture gets more complicated, look at only what you need. Okay? Now, what do we got next? Okay, we're going to start classifying. You can do it 2 ways. By the size of the angles is the first one I gave you, and the other one is by basically the congruence of the sides. Remember, congruence means what again? Same, yeah, equal, pretty much. Same shape and same similar size. So if you're going to do it by angles, well, if there is a right angle in it, then it's called a right triangle. Again, the one opposite is called that. And what are these called? Legs, very good. Okay, so if it has a right angle, the one opposite is called the hypotenuse, and the other ones are called the legs, so it's called a right triangle. If, and I don't know if I asked this question later or not, so I better look. No, I don't. So is it possible for a triangle to have more than one right angle? No, because if it had 2 right angles, that's not going to work so well, is it? How about an obtuse? Obtuse means what again? Between what 2 measures? 90 and 180, very good. So maybe that one right there is 120, who knows? Can a triangle have more than one obtuse angle? No, it cannot. And if that one right there is obtuse, we know that the other 2, we don't know they're congruent necessarily, but we know the other 2 have to be acute, right? So we can only have one obtuse. Same thing over here. These other 2 have to be acute, right? And so that's how you would make it obtuse if it has one obtuse. How about acute? Well, that's if they are all less than 90. And they all have to be that way. Do we know any of them have to be equal at this point? No. Could they be? Could they all be the same? They could be, right? Can they all be the same for this one? No. Can they all be the same for that one? Can they all be the same for this one? Yeah. All right. So that's actually what the next question says. What do we call a triangle with all angles congruent? Be very careful. I'm looking for a very specific answer, and almost always I get something that's an equivalent answer, but not the one I'm looking for. Just based on what you know right now, not any prior knowledge, what would that be called? Yes. Equilateral is by sides, not by angles. It is an equivalent answer, but we don't know that yet. Well, if equilateral means equal sides, angular. There you go. You gotta convert it there. Angular. And which of these three has a shot of being equiangular? Right, obtuse, or acute? And that's if they are all, and what would they happen to be, by the way? Very good, all 60 degrees, correct? Because we know the total for a triangle is, of course, 180, and so if they're all the same, it'd be 60, 60, and 60. So if I specifically ask you just if the angles are the same, that would be equiangular. Again, equa meaning the same, and then the angular is just a conjugation of the word angle. Okay? Now we'll go to sides. Believe it or not, isosceles is the one that most people get wrong. Anybody want to try isosceles? Mr. Friday. Close. Very close. That's why most people get it wrong. Yes? That's kind of what he said. At least two sides congruent, or the same, whatever we're doing. So that's probably new for some of you. It just has to be at least two. It can be more. Obviously, more would mean three, because if it's a triangle, you can't get more than that. But isosceles technically means at least. And please work on your spelling of isosceles. That is by far the most butchered word on tests, when people have to spell it. Ah, very good. No, that's right. I said Mr. That could be a lot of people. And I said the last name, but that could be a lot of people. Yes? We'll have to see. I think that question comes up very soon. Yes, that's a great question. Okay. So when we look at an isosceles triangle, we could go something like this, correct? Because do we know this one's isosceles as it looks right now? It just says it's isosceles underneath. Do we know that? How about now? And now we do. Okay. But before that, we really didn't know. So don't make that assumption unless the directions say that it's isosceles or something like that. Or maybe if I told you that this had a measure of 8 and that had a measure of 8, well, then you would know. Okay. But before those markings, you do not know. Okay, equilateral, I think we all know that one. I think, in fact, we had that one said already. It is the equivalent to equiangular, but all the sides are congruent. But if you truly break down the word equilateral, it means that the sides are the same. And based on our picture, do we know that right now? I mean, it says so underneath, but we don't know that. But we do know that if all the sides are the same, for example, if that's 6 and that's 6, it's obvious that that would also be 6. Yes?
So is an equilateral triangle also an isosceles?
That was the question that was just asked, and that's going to come up in a second. Scalene. I think we all know that one, right? Shut it up. No sides are congruent, or all the sides are different. So when you classify, make sure that you give me one of these three, because this would be by sides, and also one of the previous three, which was by angles. Again, they were right, obtuse, and acute. Okay? So realize you should have two of these words. Okay? Perhaps it's isosceles and obtuse. That is possible. Right? Okay? Right and scalene. That's possible. Okay? And here come these questions right here. Is an equilateral triangle a form of an isosceles triangle? Is it a type? Yes, it is. Okay, how about is an isosceles triangle a form of an equilateral triangle? Does it have to be, in other words? Okay, so in other words, this top one, is this true? Equilateral is a form of isosceles. Yeah, that's always true, right? There's no way around that. Is it possible that this one could not be true, this bottom one? Yeah, so this one I would say yes to the top one and no to the bottom one. Because isosceles doesn't have to be equilateral, but it can be. That's the key. All right. And what you're going to find as this year goes on is you're going to not just have true-false questions. You're going to have always true, sometimes true, never true. And you would think adding one possibility wouldn't make it that much harder, but it makes you think a whole lot more than just true-false. Okay? Well, let's try one. We knew algebra had to find its way back in here somewhere. Determine x and the length of each side of the triangle below. Well, before we do that, let's classify this thing by sides and by angles. Let's do by angles first. Your options for angles: right, obtuse, acute. It cannot be more than one. It has to be one of them. Yes. It is a right triangle. How do you know? Because it has a right angle. All right, it has a right angle up there by A, right? And the little box tells you it's a right, and by sides, yes, isosceles, right? Because we have the two markings there. So we know it's right and isosceles. Okay. Well, how are we going to go about this thing? Are we going to take those bits of algebra, the 6x minus 1, the 2x plus 3, and the 7x plus 0.07? We're going to add those up and set them equal to 180? No, those are the sides, not the angles, okay? A lot of people try and do that. If those were in the angles, we could try that, right? But we don't know that. But we do know one very important bit of information, that segment AB is congruent to segment AC, correct? So whatever algebra is in them should also work out to be the same number when we put in whatever x value we come up with, correct? So in this problem, we know that 6x minus 1, again, I'm going to have to find some x value that I can substitute in there, better be the same as this once I find that x value that's going to make it work. Because they were marked congruent right here. They're in the same spot. So what do you do with the 7x plus 0.07? Yeah, just leave it there. That's extra information. That doesn't help you solve for x, right? So we have a variable on each side and a number on each side. I like to move the smaller variable first. It is not the only way the problems can be done. 4x minus 1, the equal sign's still there, 3. Probably the best move now is to add 1 to both sides to get the variable as much by itself as we can. X is, very nicely, 1. You agree with 1? Is that what you got when you did it? Are you sure? Okay. Are we done? Why not? Oh, it says yes, and determine the length of each side. So what we have to do is substitute 1 right there, right there. And what should we know about those two once we substitute 1 in? They better be the same. Whatever it is, they better be the same. Does this one have to be the same? Could it be? Could be, right? Because isosceles can be equilateral. We just maybe didn't get marked. I'm guessing it probably won't be because of the 0.07, but just throwing that out there. So if I put 1 in there, it's 6 times 1, which is 6, minus 1 is 5. So we're saying that AB is 5. AC is, are we right? Is it 5? And BC, well, you put 7. Hopefully you didn't get a calculator out for that one. Now I didn't put the segments on this time. Is that correct? Not putting segments on this time. Yes, it is, because if you don't put that segment on there, it means the distance from A to B, right? And is that the distance from A to B? 5 whatever, maybe it's miles, maybe it's centimeters, we don't know, but it's 5 something. And so you don't put that segment on there when it means distance. I told you to keep track of that. That was going to be something important as the year went on. So in this case, now if on your assignment you put segment AB equals 5, I'm probably not going to come after you and mark it wrong, but keep in mind that that's what that means. Okay. A lot of notation because mathematicians, a little bit lazy. Okay, we're going to write as little as possible to get the point across. Okay. So I think so far this year, the only word that we actually have to write is plane. All right. Which is pretty long. All right. So any questions?